All right, so now we're going to look at chemical properties of the elements going across period 3. Now we're choosing period 3 because it doesn't contain any of the transition metals, but it's also because it contains metals and nonmetals as you're moving across. So the oxides of elements, sodium to aluminum, so sodium oxide, magnesium oxide, and aluminum oxide are all ionic in nature because you're transferring that electron. So the sodium, the magnesium, the aluminum are giving off the electrons to the oxygen. And so when we say oxides, we're just referring to sodium oxide, magnesium oxide, and then aluminum oxide, so that compound. The oxide of silicon being a metalloid, is a giant covalent. Sometimes you might see the word network in there, so giant network covalent. So SiO2 is what it's referring to. That is a giant network covalent. And we'll talk more about that type of bonding in our next unit when we talk about bonding. And then we are switching to the nonmetals. So your phosphorus and your chlorine, they're going to share electrons with the oxygen and therefore are covalent in nature because of that sharing of electrons. The bond character, whether it's ionic or covalent, depends on the difference between the electronegativity values. And so as you can see, as you go across that row or period 3, you have an increase in electronegativity. As the electronegativity decreases, the compound becomes more ionic. So that's why your sodium, magnesium, and aluminum form those ionic compounds, where the phosphorus and the chlorine are going to form covalent, and the sulfur. All right, some other special things there. The electric conductivity, so these ionic compounds will conduct if they're in the molten state, meaning they're a liquid. Silicon dioxide has low conductivity because silicon is a metalloid, and metalloids don't conduct as well as metals. And then the molecular covalent compounds, they don't conduct at all. So as you're going across period 3, conductivity is actually decreasing since you're going from ionic to covalent. And then finally, you have the acid-base character of period 3. So it's linked to the bonding and the structure again. Metallic elements are ionic oxides, and they form basic compounds in water. So if we take any metal atom or metal oxide and react it with water, we get that metal hydroxide. That's going to be aqueous, which allows us to break apart into the two ions there. Now notice that this generic formula is different from the way we said alkali metals react with water. This is the metallic oxide, and metallic oxides react with water to form the metallic hydroxide. So there's no hydrogen gas whatsoever. So you should be able to write this reaction with whatever metallic oxide you're given. Non-metal oxides are covalent molecules, and they're acidic in water. So you take whatever non-metal oxide you have, react it with water, and you get the acid. And then just remembering that acids donate a hydrogen, so then we can pull apart one hydrogen from that compound. And so you have the non-metal oxide and water, and it's going to form the acid. And so this is where it's just helpful to be familiar with the different acids that may form. If it's carbon, it's going to form carbonic acid. If it's SO3, you would get sulfuric acid, SO4. If it was SO2, sulfur dioxide, you would get sulfurous, SO3, as your acid. Phosphorus is there done for you. Those are the most common ones that you're going to see. But you should be able to write any of those reactions. You might want to put a little star next to this one. That one tends to throw people. All right, the aluminum oxide is considered amphoteric because it can act like an acid or a base, and so you have those two different reactions down there. Now this I know doesn't seem like it's acting as an acid, but these are Lewis acids and bases, which have a slightly different definition than what we're used to.